Hey folks, I'm Brenton. In a previous video I talked about what is threat hunting. In this video I'd like to talk about the process of threat hunting. In other words, if I'm going, now that I understand what threat hunting is, if I wanted to do threat hunting on my network, what does that process actually look like? So threat hunting is an integrity check of all of our systems on our network. It needs to be our desktops, our servers, printers, you name it. If it's plugged into the network, we need to go through and check it. We're checking these systems with the goal of coming up with one of two dispositions. I know this says three, but really there's two. And the two dispositions are, I'm pretty certain the system's safe, or I'm pretty certain the system's compromised and we're going to have a bad day / week / possibly month, depending upon how extensive this is. The third one is, I'm not sure. Well, I'm not sure simply means I need to create new ways to collect data or get additional data to be able to come back to one of those first two dispositions. So what we're really trying to do is we're trying to do a compromise assessment. We're trying to identify what is the current integrity state on each of our systems. So where do we start? The best place to start is on the network. Why? Well, we've historically done centralized logging, right? Try to get everything to centralized log, try to write some signatures, try to respond to alerts. And we have plenty of data to show that doesn't work. It takes months, if at all, to detect an attacker using those types of conditions. So start with the network, because everything we want to validate is plugged into the network. The other nice thing about the network is if I want to check host logs from a Windows system, I need a different set of skills than if I want to check, let's say, the host logs that are associated with like a Cisco router or a Linux box or a video camera or whatever. With the network, packets are packets. So the same way I would validate a Windows system is the same way I'd validate a Linux system. I don't even have to know they're different. Doesn't matter. I'm going to go through and check them out the same way. So what's nice about this is I have one consistent process I can use to validate everything that's on my network. What's that process look like? Typically what we want to do is we want to monitor what traffic is leaving our protected environment and headed out towards the internet. And within that data, we're going to look for certain things. The first thing we're going to look for is patterns of persistency. What's persistency? Persistency means my internal system is in constant communication with that host out on the internet. So it may hold the connection open all the time. It may be calling out to that host once per minute, every 10 minutes, whatever the case may be. If I'm seeing a pattern of persistency, that's something that needs to be investigated, because there needs to be a business reason for that. For example, if my system is calling out to a system on the internet on a regular basis and it's to check what time it is, that's fine. If it's calling out on the internet to see are there any new security patches that need to be installed, that's fine. But if my system's calling out to an IP address in Guangzhou, China, and I don't have a field office, business partner, or vendor in Guangzhou, China, that's suspect. That's something I need to pay attention to and dig into a little bit deeper. So once we identify connection persistency, we then want to look and say, is there a legitimate business need? Pro tip, get to know your purchasing department, because your purchasing department is going to be able to help you figure out what services is your organization paying for. So if I see a connection going to Acme Corp, they may be able to answer to me, oh yeah, the marketing company is buying products from Acme Corp. That may help me run down business need. If I can't identify a business need, now I want to look for abnormal protocol behavior. Things like, hey, it's going to TCP 443, which is normally HTTPS traffic, but it's not HTTPS traffic. It's something, encrypted or obfuscated, but it's not actually using a real SSL TLS handshake. That would be abnormal protocol behavior. We want to look for things like that. That may help make us privy that, yeah, this may be something we need to be concerned about. Numbers 4 and 5, which order to do these in really depends on your internal environment. If I collect a lot of data from my host, let's say I record every process that runs on every internal system, I may want to do step 5 before step 4. What we're trying to do is do some validation to identify Is this system trustworthy? Do I understand why this connection is taking place? For most environments that just let people connect, get a DHCP address, and then connect to the internet, and there's no controls really in place with those endpoints, you're better off going after that external IP to figure out if it's something trustworthy or not. If you do collect that internal data, it makes sense to go after the internal system first. So steps 4 and 5 can be interchangeable. It really depends upon which one is easiest for you, because we want to go through the steps that are going to help clear a system as quickly as possible, assuming it's not in a compromised state. Once I go through those 5 steps, my final step is to disposition that system. Is it a threat or not? Yes or no? If it's not, okay, whatever it was I saw that looked interesting to me, that made me go through these steps, that needs to get added to a safe list. Hey, my system is checking what time it is on this particular source out on the internet. That persistency is something we can ignore going forward in the future. What's nice about that is tomorrow or next week when I do a threat hunt, that doesn't show up anymore because that's one of my safe listed connections. System checking for patching. Don't have to look at that anymore. That doesn't show up in future threat hunts. So when you do this right, your first threat hunt might take, just to throw out a round number, let's say it takes 12 hours. Your second one may take 5 hours. Your third one may take 2 hours. And then after that, these start taking maybe 20 minutes each time, and that's it. By adding things to your safe list and eliminating them from having to be reevaluated over and over again, threat hunts can go faster and faster for you. If we think the system is compromised, we need to trigger incident response. Don't go mucking around with the box. Don't go in and immediately go into forensics or isolating it or anything else. Go into incident response mode. Have a good incident response plan in place in order to be able to deal with something like this. So that's a rundown of the steps that take place as part of a threat hunt. Hope you found this helpful.